Let f from R to R be a twice differentiable function such that f double dash of x is positive for all x belongs to R, and f dash of a minus 1 is 0 also they mentioned. So, and g of x function also they gave. Consider the following two statements. So, which is true, we are going to check it. Okay, fine. So, first of all, you can observe the function g is what? F of tan square x minus 2 tan x plus a. When 0 to pi by 2 interval only we are going to check. So, to check whether it is increasing, decreasing, we have to do the derivative only. So, g of x we can do the derivative so that we will get it as g dash of x is equal to f of x derivative f dash of x only, no? So, f dash of tan square x minus 2 tan x plus a as it is. Now, chain rule if you are applying means 2 tan x, again tan secant square x minus 2 tan secant square x and plus a derivative obviously going to 0 because it's a constant, right? We got like this. Fine. Now we have to find the critical points. So for the purpose we can equate g dash of x is 0. When you equated g dash of x is 0, what we will get it here? Observe. So g dash of x is equal to 0. That implies either it is the completely 0 or it's completely 0. We will get it, right? So what we will get it now? F dash of tan square x minus 2 tan x plus a is 0, or else from this we can observe 2 secant square x we can take it common, right? So the balance is what happened now? 2 secant square x take it outside means tan x minus 1 is the leftover is equal to 0. Okay, see, we know that secant is cannot be 0. Okay, so now the only possibility is here tan x is equal to 1. From this x equal to pi by 4 is the only critical point in the given interval 0 to pi by 2. Similarly, from this also can check it. They gave already f dash of a minus 1 is 0, right? So f dash of dash part is 0 means it's compulsory a minus 1, right? So tan square x minus 2 tan x plus a is equal to a minus 1. A is going to cancel. Minus 1 you can bring that side, so that it will become tan x minus 1 whole square is 0. From this also we will get x is equal to pi by 4 only. So pi by 4 is the only critical point. Okay. Now let's divide the given interval 0 to pi by 2 as two parts. 0 to pi by 4 is one part, pi by 4 to pi by 2 is the another part. Now we have to check the sign of g dash of x in the both intervals. Okay. So let's take in between 0 to 45 some 30 degrees and then we can check it. When you take 0 to 45 in between 30 degrees, what happened? So the second part obviously negative because tan 30 is 1 by root 3 compared to 1 small. So second part is negative. Now first part sign only we have to check it. Okay, see now. Here when you put some 30 degrees, we cannot decide this because a value is there. Then how can you find the sign of f dash of x? They gave, observe, f double dash of x is positive they gave. So f double dash of x is positive they mentioned. From this what we can conclude? F dash of x is strictly increasing function, because f dash of x derivative only know f double dash of x. So f double dash of x positive means then f dash of x is strictly increasing function. When f dash of x is strictly increasing function, now you can see here. So from the data you can observe f dash of a minus 1 is equal to 0 they gave. Okay, f dash of a minus 1 is 0 they mentioned. Okay na, right? And we found it here already f dash of x is strictly increasing function. That means what? If you take any x which is less than a minus 1, then f dash of x is also less than f of a minus 1, and f dash of a minus 1 they gave already f dash of a minus 1 is 0. That means f dash of x is negative. Okay. Similarly, if you take x is greater than a minus 1, we also can get f dash of x is greater than 0. That is the meaning of the point. Okay, now you can see here our function is f dash of tan square x minus 2 tan x plus a. That's what, that sign only we are going to check it, right? Now see, so what happened? So first of all you can observe here f dash of tan square x minus 2 tan x plus a is there. We can add plus 1 and minus 1 then we can write the entire thing as tan x minus 1 whole square plus some a minus 1. Like this we can write. Okay na? So this is the sign, we are going to check it now. So you can observe it's a perfect square. It's a perfect square, right? So if you take any value in between 0 to pi by 4 and then we can substitute some positive quantity, you will get. So what we can understand from the point means the entire value tan x minus 1 whole square plus a minus 1 definitely greater than a minus 1. Okay na? So if you are applying the f dash of x on both side function, f dash of the entire thing must be greater than f dash of a minus 1. So f dash of a minus 1 value 0 only. So what we can understand means here f dash of the entire value is must be positive. So here we will get the sign is positive and here already we got the sign is negative. Okay na? So when you multiply positive into negative, we will get the entire sign is negative in 0 to pi by 4. Similarly, if you take any value in between pi by 4 to pi by 2, the second part is positive we will get and the first part already we found it, no, positive only. So positive into positive will be positive, we will get it. Okay na? So from the option, what we can conclude overall actually question lo. So f is, sorry not f, g function, right? G is decreasing in 0 to pi by 4 and g is increasing in pi by 4 to pi by 2. So see the first option increasing they mentioned, so wrong. Second one is decreasing they mentioned, so wrong. So both are wrong, so our option is first one, neither one nor two is true. Okay.